By the end of this video, you will know how to connect your network to AWS VPC using real-world configurations. This is how companies use them in production. And this is a must-have skill if you are in cloud or networking. Thank you for us to be able to connect to it via On-Prem. So let me verify here. Okay, it's working. It's working. So that's that. So there you have it in real time. So now let's confirm whether our tunnel is up. Tunnel, are you up? Voila! Oh, beautiful. There you go. It's up. Welcome to my channel. I am Network Reggie from Lagos, Nigeria. I have multiple certifications from Cisco, CCNA Routing and Switching, ICMP Routing and Switching, now known as Enterprise Infrastructure, and even my CCIA that has now been retired in Routing and Switching. I've also done the lab on this channel, and I also have some cloud certification, online certification for Amazon AWS with extensive training, and I've also had a couple of projects in AWS, equally Azure, Microsoft Azure. In this channel, I'm helping you bridge the gap between theory and the real world. Whether you are studying for certifications or building solutions for clients, or you're a remote worker, I provide hands-on video solutions using tools the pros use. And note, the tools I will be using on this channel will be free, the free version mostly. My goal is simple: execution and perfection. If that sounds like what you are looking for, please like and subscribe and join the journey. Now let's get into the lab. So here's our VPC. There's a few things we need to finish. Now I'll click on our subnets. Yeah. Our private subnet, which is this. Click on actions. Click on view details. Now we are supposed to allow we are supposed to auto-assign. We are supposed to allow it to be able to assign public IP version 4 address to it. Now that's for us to be able to connect to it. So I'll click on actions, edit subnet settings, scroll down here and enable auto-assign public IP version 4 address. Hostname, okay, resource name, okay, no, IP name is fine. All right, okay, click on save. So that's for public 1A. So now, click on subnets. I go and do public 1B. Let me see if I can get, okay, no. Click on subnets, actions, edit subnet settings, enable auto assign IP version 4 address. I click on save. Now I go to my VPC. That's our private data center in the cloud. Click on it. Click on actions, edit VPC settings. Okay, let me take away my head here, and I will enable DNS host names. Click on save. Okay. So now, there's a few things I would like to show you before we get into nitty-gritty. Now for the network register public 1A, if you observed, and I click on it, scroll up. Click on it here. You observe here the CIDR notation is 10.0.0 10.0.1.0/24, and it is saying available library version 4 addresses is 251 instead of 254 as it is on-prem. But this is the way it works in the cloud. Yeah. For example, you can also see it here. If you scroll all the way here, you will see it here 251. Yeah. So we have to put that one into consideration. Now, normally in the traditional network, that's our on-prem network. Yeah. We have normally if it is 10.0.1.0/24. Normally it's on-prem. On-prem it will be 10.0 .1.0. It's always is the network address. That is default. And normally 10.0.1.255 is the broadcast address. Yeah, broadcast address. However, in AWS, in addition to these two, in addition to these two in AWS, we have the 10.0.1.1. That will be the VPC router. That is the router connecting that will connect our EC2 instance to the network. So that is reserved for the VPC router. 10.0, sorry, don't mind my awkward writing. 10.0.1.2 is for the DNS, AWS DNS. It is reserved for the AWS DNS. So now 10.0.1.3 is reserved for future purposes. So that is why if you observe my network here, I put .4 as the first IP address that my network ready AWS server will adopt. So now let's go in and do the first thing. Let's create our EC2 instance. So now I'll click here, click on in this place and click on EC2. Okay. So I'll click on instances. Then I'll click on launch instance. So I'm going to name it according to our topology. NRAW server, okay. Network ready server, okay. So that will be NRAWS server, okay. So now I've left it out on Amazon Linux by as default because we're in the lab. I selected the free tier eligible. Scroll down. Okay, so teach 5 macro, okay, still eligible. I can create keep here, but in this instance, I don't need to create keep here. We will use the EC2 connects. So resource group, let me use the default. I don't need to create. Okay, just use the default. Scroll down again. What else you need? Okay. Oh yeah. So now the important thing here, network settings. This is where I'm going to select our VPC, which will be the network ready AWS VPC. That is where we are putting it. And then our subnets, we are selecting the one in availability zone public 1A. Availability zone public 1A. The subnet you are selecting here. You can see auto enable, auto assign IP public IP selected by default. Okay. So this one is telling me that that default security group is not in the, it's not the one in the VPC that I selected. So I'll click on drop arrow and then select the default one that will be in the VPC of network ready VPC. So that's okay. Okay, that's it. So after that, I just click on launch instance. Proceed with our keep here. No worries, no worries. Doesn't matter. So if you're still initializing, wait for it to initialize. And the first IP address in the peak is from .4 all the way to 254. Okay. It is now running. Okay, so let me connect. So click on connect. Connect using public IP, yes. So you're using our EC2 instance connect. So I would like to show you the router here. A few things that I explained, that you guys can get it. Okay, but let me check my security group. Security group. Let's check what are we allowing inbound. Allowing all. So let me see which one is for. Let me see this one particular one. I want to be sure the one that we are going to work with. So which one? Okay. So NRAWS VPC, network ready VPC, that's our virtual data center and cloud. That is 05C at VPC ID. Okay. 05C. Okay. So that's the one at the bottom. All right. So I click on actions, editing bound rules. So let me add the SSH. SSH from anywhere. So I've told you to allow SSH in. Let's wait for it to accept it. Okay. So I get it. Yeah. Inbound rules. Let's confirm the SSH is showing up. Okay, all right. Okay, so now let's refresh. It should work now. Good. So now I have config. I want to know. Okay, so as you can see here, as you can see from our instance, network region AWS server, we see our private IP address is 10.0.242. That is what our VPC assigned to it, and that's what we can see here. Okay, so now let me take away my head. Okay, now I'm going to do routes. So here you can see this is the router as the gateway for our VPC. That is where we are connected to, that will connect us to the internet. 10.0.1.1 as is reserved. Okay, so that is that. Right, that's that. So yeah, another tip I would like to add to it, if I go to my VMware, yeah, I click on Edit, click on Virtual Network Editor, then I click on Change Settings. Okay, and I click on NAT. Yeah, if I click on NAT settings, you will see that's the gateway IP. It's 192.168.159.2. That is where I always get the .2 that I use in my lab, because that way we need to get your access internet, point our default route to that, and also the DNS. That is that. And another thing, I'm just trying to compare similarities with the VPC subnet. You can see here, you see here enabled. If I click on you can see subnet IP, the range is 192.168.159.0 all the way to 255.255.0. Yeah. So to see the router, the workstation router, that's the routing table. And then for the DHCP, if I click on DHCP settings, these are the IP addresses that will be assigned from 128 to 254. So that is that. Now, in order to see the IP address of the server, okay, in order to see the IP address of the server, you can click on my terminal window and click on ncpa.cpl, ncpa.cpl, and this will open the control panel, network interface control panel. So you will see this is VMware network adapter VMnet 8. So that's it. I click on it. Click on view status of the connection. Click on details. You see there 192.168.159.1. That's the router. You can also click on properties. IP version 4. Click on properties again. That's it there. So that's that. So technically, VMware Workstation is my own private cloud, my own vicinity. So that's where I installed AVNG, from which I'm doing all my lab connecting directly to AWS server. So now it's time to get into the nitty-gritty and configure our site-to-site VPN. So the first step now is to go back to VPC. I will scroll down to the section known as Virtual Private Network VPN. So the first thing we are going to do here, we'll create our customer gateway, then we'll create our virtual private gateway, and then we'll create our site-to-site VPN connections. Okay, so I'll click on customer gateway. I'll click on create customer gateway. NR, let me confirm again. NR Solutions Limited, Lagos, Nigeria. NR Solutions Limited, Lagos, Nigeria. Our BGP ASN, normally AWS does a good favor. So for the BGP, our ASN has our autonomous system number. We are going to be using the private ASNs, that is free. So, and the private start from 64,512 all the way to 65,535 for the 2 bytes. And for the 4 bytes, the same thing, 64,512.64,512 all the way to 65,535. Yeah, so that's that. So here, it's saying we should use 65,000, which is okay. But I like to change it to what I would like to use. Let me just say 64. Let me say 65. 512. That's fine by me. Okay, so now it's telling us to specify the IP address for the customer gateway device external interface. Now, that means it's asking, we need to provide our public IP address. That's public IP address I am using, not the one inside the EVNG. So this is what you take note of. It's not the IP address in the EVNG. Those are private. We need to give it our public IP. And how do you get a public IP? On the browser, you type what is my IP address. So that is the way you can see your public IP address. You type version 4 and version 6. So I'll click on my address. So this is my. So that's that. So once I put the public IP, click on create customer gateway. So I have created it with my public IP. So now, next step, click on virtual private gateway. So now this is the AWS side of things. Click on create virtual gateway, and that will be NR AWS VPC. So it's telling us, should we use the default or use custom? Yeah, let's use custom. Custom, we just use 64,513. That's it. Create virtual gateway. Now it is telling us it's detached, so I need to attach let me refresh. Okay. So now I click on actions, attach VPC. So if VPC I will try to connect to, that will be network AWS VPC. And click on attach VPC. So still attaching. So after this, I need to go to my route tables. Let me see whether it will be ready for me. Okay, route propagation, yeah, okay. So now route propagation, and I'll click on edit route propagation. I'll click on enable. So after we've configured your customer gateway and your customer gateway, that is our for on-prem data center, our IP version, IPSec VPN section for customer section, and then the AWS VPC, virtual private gateway for the AWS VPC, our private data center in AWS. Then we go and enable route propagation, telling it we're expecting some routes. Then I'll come back, click on site-to-site VPN. And now click on create VPN connection. And here I'll now call it S2S. S2S, which is site-to-site. So you say target gateway type, I think we are just using our virtual private gateway. So selected it. As you can see, AWS VPC. Customer gateway here, we are using our existing customer gateway. I'll click on it. So that's it, and that. So dynamic. So it's asking us which options are we using? Which routing option are we using? Is it dynamic or static? Because that's the only two ways you can connect to either your ISP or your CSP. ISP, Internet Service Provider, in this case AWS, they are our cloud service provider. So we can either use dynamic or static, and dynamic is only BGP. Static, you all know static. So I said BGP. So it's asking for the pre-shared key storage. So you use the standard one. That's it. The remaining things, you all leave them as that. There's no now I'll click on create VPN connection. Okay. So I refresh. Click on it. Now, after clicking on it like this, I'll now click on download config. Now before we click on the download config, we will come here and click on details. You see the transit gateway. These are all what we've configured earlier. Then if I click on tunnel details, you will see it's down. When we finish configuring it, both tunnels will be up. The first one is enough to do our work. The tunnel 2 is for redundancy. So those are the IPSec tunnels. IPSec stands for IP security. Those are the tunnels that will allow us to go through via the internet securely, connect to our private. The VPNs will mask our private IP addresses from the internet, and connect us directly to our AWS VPN. So I click on download configuration. Now when I click on direct configuration, I'll look for our vendor. Now in my case, it's Cisco. So it's Cisco. So in the future, when we want to do Palo Alto, you see it Palo Alto. And if it is Fortinet, see it Fortinet. So but for now, we are doing Cisco. So it's asking all the series. We know it's a virtual firewall, so yeah, that's fine. So this is fine. Then I'll click on download. And now I'll now call it S2S config. S2S config. Now click on cancel. I'm going to go to my Notepad++. Click on my Notepad++. File, open. S2S config. Yeah. So this is the config from that AWS is giving us. Now they've configured their side, so we will configure our side. Just the way it is with on-prem ISPs. When they configure their side, they will give you your site to configure via email and all of that. So first thing I need to do here we go through all this, because remember in the lab, for site-to-site VPN, we are being charged per hour. So since I already know what we will need, I will need to edit this. You can see crypto IP. We are going to create our IPSec IC version 1 first. So here I need to get the name of this outside interface. So let me go to my firewall, click on RLFW, click it, show name if. So the name, what we call our outside interface is outside. Okay, so I'll just press Ctrl F. I'll look for find and replace. So what I'm doing here is outside interface. So anywhere you see outside interface, change it to outside for me. I'll say replace all. Anywhere it sees this, just change it to this. That's it. Oh, and then replace. Yeah. Okay. All right. So that's that. So now we scroll back up. So now to create our first tunnel, this is the IC version 1 as internet key exchange configuration. So all I just need to do is copy this, crypto IC version 1 enable, blah, 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 all this, copy it, right click, copy. I go to my AWS firewall, I paste. Then I scroll down to the IPSec config. That's the next step. This is where we are configuring the transform sets. Copy. I click onto it. What is happening? Okay. I think I need to exit here. Good. So scroll down. Now we need to configure the IPSec profile. Copy. Exit. Now scrolling down, these are the additional parameters of the IPSec configuration set here. So it should be crypto. These are the additional parameters. Click on it. This is my firewall. Click enter. Then let's go here. This option causes the firewall to reduce maximum segment size. Okay, this is for TCP MSS. TCP maximum segment size. So everything is well detailed and explained in documents. So here, for the gateway window for accepting out of order IPsec packets, let's copy this. So now for those of you that are new to this, if you can decide to copy everything, because this hyphen mark here will not allow these ones to be saved on the router. But I'm showing you the right way to do it, an ethical way. So here, so copy. Okay. That segment size, yeah. Okay. Crypto IPsec security window size. Copy. Okay. Then After that, the option includes the router to fragment the unencrypted packets. Okay. Crypto IPSec fragmentation before encryption. This outside here is the name of our interface. See? Now this, if you see this error invalid input detected as, that means there's an error. Maybe I'm supposed to be in the config mode or in a particular mode, and I'm not there. So just check it, verify it, and do it again. Make sure it's correct before you continue, because otherwise the tunnel interface will not come up. So scroll up. So now it's time to configure the pre-shared key. Copy. There you go. Okay, so this option enables IPSec dead pair detection. So now copy this, paste. That's it. We haven't configured the tunnel yet. We've configured the IPSec version 1 and IPSec version 2. So now it's time to configure the tunnel. Tunnel interface config. So you read all that. And then after that, you will replace the outside interface. We've already done that with the outside interface with the name of your So, and this is it outside. So yeah. Click here. Just copy everything. This yellow sign here indicates, if you recall, that when I click the Control F, find and replace, because I edit this arrow here means I edited this particular line in the config. So now I paste. Okay. So now it's time to verify if our tunnel interface is up. That is very, very important before we continue. Good. So you can see it's up. It's up. That's very important. If it's not up, then we have to go back and check our config. Maybe we skip a line or something. Okay, so scroll down again. Now it's time to configure the BGP, Border Gateway Protocol. That's the routing protocol of the internet. So here you can see all what we've done. Our customer gateway site, this is it here, Router BGP 65512. So it gave us the IP address which you use and all of that. I copy that. Then I'll come here to the firewall and paste it. You can see it did not put exit. Now say to advertise additional prefixes to Amazon VPC, copy the network statement and advertise the prefix you want to advertise. So now this is the remaining things we will need. Now, so that's by the way. So now in our configuration here, I've already enabled we have two subnets, 192.168.10.0 and 192.168.11.0/24, both of them. However, this is what I want to do, because the next video after this will be AWS Cloud Hub. So in which case I have to create multiple on-prem data center branches. Outside of Lagos, I'll pick 3 other locations in other parts of the world, one in USA, one in China, and one in the UAE. Yeah. So I would like to break down the subnet. I would like to aggregate the subnets in a way to be more effective, to demonstrate the way we will do it in the real world. So I will be using, in this place, I'll be using 192. Let me see. 192.168.0.0/24 to 192.168 dot 15, sorry, 15 dot 0/24. These are the subnets that we are going to reserve for Network Ready Solutions Lagos, Nigeria. However, so in order to aggregate this, we are going to aggregate it based on the third octet. So you can say 192.168.0.0, 192.168.15.0. So how do we aggregate this? We say 192.168.0.0, 255, 255.255.255.0, which translates to this. And how do we get this /24? It translates to 8 plus 8, because 255 is 8, 255 is 8 plus 8, which will give us 24. So now we know that, so let me write it down. 1, 2, 4, 8, 16, 32. Okay, I'm out of space here. Okay. So 1, 2, 4, 8, 16, 32, 64, 128. So now, in order for us to get the accurate aggregate address that you'll be able to aggregate this accurately and not go above, I'm going to I'll put this bit on 1, 2, 1, so making it 1 plus 2, 3, plus 4, 7, plus 8, 15. So the remaining will be all zeros. 1, 2, 3, 4. So that way, now these all zeros here, we will add it to 8 plus 8. So we should now give us 20. That's 8 plus 8 plus 4. It should now give us 20. So the aggregate address will be 192.168.0.0/20. And when we do the subnet class for the CCNA, when I do the subnetting for CCNA, I will explain further and better and more clear here. So that's that. So let me demonstrate what I mean here. So now the first thing, I'm going to say network 192.168.10, because we are doing .0, that's the network. And then the mask will be 255.255.255.0. Now I'm going to say aggregate 192.168.0.0, 255.255.240.0. That's it. That is it. So I got to show BGP summary. Yeah. So now you can see our summary. So you can see this is our IP address from what's it called? From our AWS VPC server, and this is the IP address advertising. Okay, sorry, I made a show wrong router BGP. Yeah, I want to make it summary only. So it will not advertise any, because by default, AWS is allowing us to advertise only 100 subnets, 100 IP addresses per client. So in order to save our IP addresses, since we are still going to have other branches and all, for scalability, in order to have enough IP addresses to use, I'll make this summary only. I'll exit. So show BGP summary. So now you can see this is now suppressed. So this is only what you are going to see on the AWS side of things. So now let's go to our VPC. I need to refresh for us to see our tunnel up. Okay, beautiful. So you can see now our tunnel is up. We are yet to configure this other one. So when we configure it, it will come up too. So let's go and check our route table. For it to know the reason why we enable route propagation, I'll click on routes, drag it down, refresh, routes, there you go. That is it. You can see it. Virtual private gateway. See? Okay, no, sorry. Okay, you can see it for virtual private gateway 192.168.0.0 coming from there. In order to see better, let me click on it. Okay. So you can see we are getting this one via the VGW, that's the virtual gateway, virtual private gateway, and all of that. Okay, so that's that. So now we'll come to our EC2 instance. I'll do routes. Let me see whether we can see the routes there. Okay, this is not showing anything, but we can see it in the gateway. So now let me ping. Now that we see that our what's it called this up, our site-to-site VPN is up, I'll come back to my firewall. I'll say show crypto ICMP SA. So that's that. So you can see when you see active in a firewall, Cisco firewall, it means our version 1 is up. IPSec ICMP IC version 1 is up. So now for the IC version 2, we should allow the gateway to be up with show crypto IPSec SA. I will hit enter. Okay, so that's that. And see, it's a long story. So when you see this, it simply means it's up. The tunnel is up. So now I can ping from my EC2 instance, ping 192.168.10.1. Now see 5 times only, please. Okay, so that's that. It's working. So I want the piece to go to. So now let's try for the 11.1. So now we can connect. So you can see it's working. Even though I didn't explicitly give it, I did not explicitly configure 11.1 on the BGP. The visual run router BGP, I only configured the .10, but because I've given it this aggregates IP and the range, that is why it can ping .11. Now, if I do show routes BGP, so you can see the BGP we are receiving. This is from the AWS side, and this is the one we are advertising to it. Another way you can see is show BGP summary. Okay, Control W, we delete the immediately one for it. So show BGP neighbors. And then I click this. That's our neighbor. I right click here and I say advertise routes. You can see this is what we're advertising. This is the only thing we're advertising. So this is one way to verify what you're advertising, apart from checking the routing table of AWS site. You can check it locally here. Yeah. So that's that. Okay. So now I would like to, on my switch here, I would like to confirm, because that's what we do in the real world, in order to be certain that we are not advertising more than that range, which is 192.168.0.0 to 192.168.15.255. So for me to test here, let me just enable the loopback, surface loopback 0, IP address 192.168.0.1, 255.255.0. Okay, 1, so 1, and say this is a bonus, so 2, 3. So this is one way to test. So I'll do like that, 4, 5, 6, 7, 7, 8, go to 10. No, we have 10 already, sorry. We have 10. Into 8, no. We have 11, so we just go to 12, 13, 14, 15. Now I'm going to put it 16, but I know it's not going to work. It's just for you to demonstrate to you the idea behind it. So I'll say show IP interface brief, so you can see all the loopbacks from 0 to 16. So now I can come here and use this okay, okay, see this, and then done. Fantastic. Okay, I got it. So you're pinging note 1, dot 2, dot 3, dot 4, okay, dot 5, 6, 7, 8. So this is one way to test this thing before you go to site, so you know that no problem is going to work. Okay, 10, 11. As for that night, I didn't think of this idea before, so it was on the firewall, so no problem about that. 12, 13. So this is one way to test. Just batch pingle. Good. So that's that. So that's the command for IP in. Okay. So Now let me now ping the 192.168.16.1. I know it's not going to work because it is not within the range. So there you go. Get that? It's not going to work. So that's how you know that your aggregate IP, that's one way to test that it's working. So that is that. So now let me configure the other show interface IP brief. That is the way you can verify that it must be up. Show BGP summary. How's that? So now let me configure the other tunnel so that our VPC tunnel can be up. The redundancy can be up, sorry. So you can see. So now this VPN connection is not using both tunnels. So the mode is not highly available. I strongly recommend you configure the second. So yeah, so that's what we're about to do now. So let's go configure the second tunnel. I haven't done the first one. We are just going to use the same method to do the second tunnel. That's it. That's it. So now we are going to go quicker. Copy. So we already know we must exit before we paste this. So the next is the IPSec profile. Okay. So after that, so we do the clear defragments, hit enter, copy and paste, do this, and then we do this. Please like this video and share, and also comment on what you would like to see going forward. I will be bringing you hands-on lab. This channel will be basically built on hands-on lab, getting you to have the skill set to help you in real work without working as a remote worker or preparing for certifications. Please subscribe. Okay, so now we're enabling the tunnel. Yeah. So now it's time for the BGP. Yeah, since we've done it before, we don't need to put any network. It's the same BGP, so we just need to configure the neighbor, the second neighbor. That's it. Exit, show BGP summary. Okay, so this other neighbor is still coming up. Good, it's up. So one of the things to check first, we do show interface IP brief. See that both tunnels are up. So now we come here to the VPC connection, site-to-site connections, click on refresh. Sometimes it might take a while, so don't be worried. As far as the firewall is up, this one will definitely come up. So we've seen it up, so this will come. Sometimes it takes a while. but it will come up. It's taking a while here, but if you look at it from here, show crypto, ICMP SA, we can see both are up. MM active, show crypto, IPSec SA. So you can see first tunnel is up. Tunnel 2 is up. And you can see it's encrypting 31, decrypting 28, digest 31, verify 28. So it's working. It's just taking a while for the web interface to load. So it's working. But I will wait for it to be off before I shut it down. Maybe I should refresh the whole interface. But this thing is up. Okay. And for those of you that will be like, network reg if not verified from the client side, okay. So let me open the terminal here. What is the IP address of IC2 instance? File config ATH0. Okay, it's ENC5, ENS5. It's 10.0.1.42. It's okay. So come here. It's a ping 10.0.1.42. Count 5 times, please. Why is that? Okay, I'll come here to PC1. Let me check. 10.0.1.42. From here, let me ping 192.168.10.1 5 times. 11 5 times. Okay. So, okay, let me check the security group. Maybe I need to enable the ICMP then. Since I cannot get through from on-prem, then I will need to enable the ICMP. So let me add a rule. ICMP. Yeah. So save rules. Okay. So let's verify the rules are there. Okay. Okay. All ICMP. Okay, good. So now let me ping from on-prem and see. Oh, okay, okay. Okay. All right. So there you have it. I needed to enable the ICMP for us to be able to connect to it via on-prem. So let me verify here. Okay, it's working. It's working. So that's that. So there you have it in real time. So now let's check, let's confirm whether our tunnel is up. Tunnel, are you up? Voila! Oh, beautiful. There you go, it's up. So you can see 2 BGP routes. So redundancy, it's redundant, 2 BGP routes. Yeah. So these are all the configurations for what you configured for the tunnel. And if you want to see the route tables, you go to the route tables, NR main route table, click on routes. Let me just click it, okay. Remember, we must have enabled route propagation. Then come to routes. And then we can see the 192.168.0.0/20. That's BGP route coming in via the virtual private gateway on these default routes. What the hell is default route? Okay, anyway. So that's that. So we have to allow ICMP in. We have to allow ICMP in our security group in order for our on-prem to be able to. Our on-prem, that is our PC1 in sales department and engineering department DP1, for them to be able to ping our NR AWS server. Okay, so that's that. If you want to learn cloud and networking and you are serious about it, this is a skill you must have. Make sure to like this video, subscribe please, and leave a comment. I will be bringing more real-world cloud architectures to you. Thank you for watching.